Yeah, good evening all. Today I would like to discuss about problems on mesh analysis. Okay, now see here, from the given circuit, calculate current flowing through resistor R5 by using mesh analysis. See here, that means here I need to calculate current flowing through this 5 ohm resistor. Okay, step 1, we need to identify the number of closed paths, right? This is one closed path. Okay, that is loop 1. This is another closed path, loop 2. Okay, this is another closed path, loop 3. Okay, loop 1 current direction is I1, loop 2 will be I2, loop 3 current is I3. All currents are in clockwise only, right? Okay, first consider apply KVL to loop 1. Right? Okay, for loop 1, polarities across passive elements will be in clockwise, plus minus, right? That is for minus plus, minus 50, for plus minus, plus. Voltage across resistor is nothing but current flowing through that branch into that branch resistance, right? That is current flowing through 5 ohm will be I1 into 5, again for plus minus, right? 10 into, see here I am considering loop 1. When we consider loop 1 current magnitude is greater than remaining loop currents, right? That is I1 is greater than I2, I1 is greater than I3. That is, then current flowing through that branch will be I1 minus I2 is equals to 0, right? Algebraic sum of voltages in a closed loop is equals to 0. First write I1 terms, that is 15 I1 minus 10 I2 is equals to 50. Assume equation number 1. Okay, next similarly apply KVL to loop 2. Okay, here loop, when we consider loop 2 current magnitude is greater than remaining loop currents, right? That is I2 is greater than I1 and I2 is greater than I3. Now see here, for loop 2, here I need to give polarities, right? In clockwise, plus minus, plus minus, plus minus. Okay, then current flowing through this 5 ohm will be I2, right? That is plus 5 into I2, again plus 10 into here I2 minus I3 plus 10 into, see here it is connected between loop 1 and loop 2, right? I2 minus I1 is equals to 0, right? First write I1 terms, that is minus 10 I1. Next write I2 terms, 5 I2 plus 10 I2, 15 I2 plus 10 I2, 25 I2. Next minus 10 I3 is equals to 0. Assume this is equation number 2. Next apply KVL to loop 3. Okay, for loop 3 again plus minus, across passive elements polarities will be clockwise, plus minus. Okay, for this plus minus, plus 5 into I3 plus minus, plus 20 plus minus, plus 10 into I3 minus I2 is equals to 0. Okay, then first write I1 terms, no, there is no I1 term, then minus 10 I2 plus 15 I3 is equals to minus 20. Okay, by solving equation 1, equation 2, equation 3 in calculator, you will get I1 value, I2 value and I3 value in amperes or milliamperes, whatever it may be. Okay, now see here I need to calculate current flowing through R5, right? Then the current flowing through R5 is I5, sorry, current flowing through R5 is I3. Okay, that means I3 current is flowing. Okay, while simplifying, see here in calculator we are having to solve equation ax plus by plus cy, ax plus by plus cz is equals to dn form is their option. That means x, y, z are the three unknown quantities. Here x is nothing but I1, y is nothing but I2, z is nothing but I3. Okay, to solve that problem you need to mention each and every constant. Here x parameter is present, y parameter is present, z parameter is not present. That means you can put 0. Here 3 parameters are present, no problem. Here also x parameter is absent, right? Then you need to mention 0. Then only you will get exact answer. Okay, next, last problem in mesh analysis. Okay, see here calculate voltage between A and B terminals. Okay, voltage across A and B terminals. Okay, to solve this problem, first apply KVL here. Loop 1. Okay, based upon this battery polarities, again based upon this battery polarities, you can consider this is the direction of loop currents. This is loop 2. Okay, here I am assuming no current is flowing through this branch. Why? Because see here this is the direction of current, right? Here there is no closed path to flow the current, right? Okay, that means if I apply KVL here, apply KVL to loop 1. Minus 10 plus 2 into I or I1 plus 2 into I1 is equals to 0, right, from this loop. Okay, then 4I1 is equals to 10. I1 is equals to 10 by 4. Next, similarly apply KVL to loop 2. Here for minus plus minus 20. Okay, again plus minus in anti-clockwise direction, right? Then plus 6 into I2 plus 4 into I2 is equals to 0. Then 10 I2 is equals to 20. I2 is equals to 20 by 10. It is 2 amperes, right? After knowing this value, see here my aim is to calculate voltage between A and B terminals. Okay, that is nothing but VAB is nothing but VA minus VB. Potential difference between VA minus VB is nothing but VAB. Okay, to calculate this value, here I need to calculate, just here I am indicating another potential D, E. Okay, now from this point to this point I need to apply KVL again. Okay, then for your understanding purpose I can draw like this. Here A potential, 2 ohm minus plus 4 volts. Okay, ohm, it is E potential, 4 ohm B potential. Okay, just your understanding purpose only I am drawing like this. Okay, but here from this point to this point no current is flowing. You can remember that point. From D to E no current is flowing. Okay, now here I am applying KVL. See here in electrical circuit everything will be assumption. See here VA present means plus is present, somewhere negative is there. Similarly here VB also, plus is here, somewhere negative is present. Now see here, assume this is the direction of current. For minus plus, minus VA. See here this is the direction of current, right? Based upon this current plus minus, right? plus VAD. Again here it is minus plus minus 4. Here I am indicating plus minus but 0 volts. Why? Because I am assuming no current is flowing, right? Plus 0. Again plus voltage between BE is equals to 0. See here, the voltage between A and B terminals is equals to, sorry, A and D here. This is AD, right? Voltage between A and D terminals is nothing but current flowing through that branch into that branch resistance, right? That is I1 into 2 ohms. That is 10 by 4 into 2. That is 5 volts VAD. Similarly, VBE is equals to voltage between B and A terminals is nothing but, okay, 4 I2 into 4 ohms, right? I2 value will be 2 into 4, that is 8 volts. Now see here, minus VA plus VAD value will be 5 volts, minus 4 plus VBE value will be 8 plus, sorry, here VB is also there, right? For plus minus plus VB is equals to 0. Okay, plus VB is equals to 0. Then VA minus VB is equals to, VA minus VB is equals to 13 minus 4. Then VA minus VB is equals to 9 volts is the answer. That is VAB is nothing but VA minus VB, that is equals to 9 volts. Okay, thank you all.